Hi, I'm Ryan Baker, and this is Big Data Education. In this video, we're going to discuss multimodal learning analytics. And I want to give a shout out to Icho Rachel Zhou, who gave me some comments on an early draft of these slides and some advice. Thank you. Multimodal learning analytics, according to Blickstein, is a set of techniques that can be used to collect multiple sources of data in high frequency, including video, logs, audio, gestures, biosensors, synchronize and code the data, and examine learning in realistic, ecologically valid, social, mixed media learning environments. And the emergence of MMLA was in response to earlier and, let's be honest, still ongoing work that focused on interaction log data because it was the easiest to obtain, relatively easy to work with, relatively easy to scale, and apply in the real world. Ochoa says, looking for solutions where it's easy to search, not where the real solutions are most probable to be found. Now, I actually think that there's a lot of value in interaction log data. I think there's a lot of things you can best study through interaction log data, and a lot of contexts where it's a very natural data source. So I would be a little bit hesitant to go that far, but there's no question that there are problems where multimodal data is a lot better. And there's a range of types of data out there. Really, when we talk multimodal, we think, first of all, more than one mode, but second of all, oh my gosh, all the possible modes. There's keystrokes, there's mouse movement, there's eye movements and pupillometry, there's EEG, there's electrodermal activity, there's galvanic skin response, there's motion sensors, there's skeleton tracking and posture, there's prosody and cadence. I've got some weird prosody and cadence right now, right? There's video, Zoom video, webcam video, video cameras in the wild, there's audio, Zoom, personal microphones, room microphones, there's location tracking badges. My gosh, where do you even start? Ochoa has an answer. Ochoa proposes a process of MMLA that starts with defining your constructs of interest, designing your system, conducting your recording of the multimodal data, conducting your feature extraction on the multimodal data, fusing the multimodal data together, we'll talk about that in a second, conducting your behavior detection and construct estimation, and then finally using your detectors in some sort of model, for example, feedback to participants. So what's special about multimodal compared to unimodal is that combination of sensors which you've got to design. And then you've got to conduct multimodal feature extraction. Feature engineering practices have developed for each kind of type of sensor, and often this work, interaction log data education really kind of came out of EDM and LA, but for other kinds of sensors like that long list a minute ago, other communities often have come up with practices for how to do feature extraction of that kind of data. And specific expertise really is needed. Like, this isn't something where, like, I, as somebody who mostly work with interaction data, can just go and say, oh, I'm going to do some good stuff with your galvanic skin response data. It really requires some expertise. Once you've extracted the features, you then have to think about multimodal fusion. And Lahat et al. Has a nice paper on that. One approach is feature engineering on each type of data, and then you take all the types of data and you throw it into the classifier together. An alternate approach is to conduct feature engineering multimodally, creating features that involve multiple data streams. And this is often needed for the data labeling step too. So multimodal fusion, we often think about in terms of the predictors, but in fact we often need it for the data labeling step too, because often our data labels that human beings are going to make actually consist of things that involve multiple sources of data at the same time. So some key challenges to multimodal learning analytics. First one, it's a big one. Every project's a one-off. Different goals lead to different sensors and different measures and different extraction processes. And it's hard to build from one project to the next because each of these projects often have a different combination of sensors for different tasks. Another big challenge, Ochoa notes, and I kind of foreshadowed that a few slides ago, was that there's multiple types of technical expertise needed. Each type of sensor you use, plus the multimodal fusion. There's also practical challenges around cost, robustness, scalability, as well as ethical concerns about multimodal measurement. Some people get very concerned about having video or EEG or galvanic skin response bracelets on kids. It's worth noting that I've kind of focused on prediction modeling in my discussion here, but in fact, any EDM or LA method can be multimodal. In one particularly ambitious paper, Jan and colleagues conducted correlation mining, prediction modeling, discovery with models, I'll talk about that next week, epistemic network analysis, and a qualitative methodology on a single multimodal dataset. I get tired just thinking about it. Given how exhausting it is, how do we make this a little less painful? One thing that's making it less painful over time is improving foundational technology. For example, better tools for high-speed auto-transcription like AI Whisper. Used to be that getting a transcript meant hiring a transcription service where some poor person would actually go through and write it all down. Or a complex procedure with multiple grad students who you had to train and make sure and check against each other. There's also been, over time, improving algorithms for things like eye tracking from webcams. Stephen Hutt and Caitlin Mills and their colleagues showed that we can now do a lot better with webcams for eye tracking, even on people across skin color and eye color. And another big improvement in foundational technology is simply cheaper gadgets for everything. If we can have much cheaper sensors, then we can deploy the sensors at much greater scale. So going forwards, MMLA is demonstrating a lot of potential. There's some challenges for it to fully achieve that potential and scale, so watch this space. So towards the future, MMLA is demonstrating a lot of potential, but there are some core challenges for it to fully achieve that potential and scale. Watch this space. By the next edition of this course, we may be seeing some exciting new things here. In fact, we probably will. Thank you very much.